Oh, and thank everybody for coming or being online with us today on our NMC webinar. My name is Keith Engel. I work for GIA. I'm on the board of directors for NMC and a long time honored to be an NMC member. Today, our webinar is on embracing the robot uprising, producing high quality milk and robotic dairies. And Dr. Brandon Treichler is our presenter today. I first met Brandon when we were doing a short course together with Norm Shearing and Dr. David Reed a very long time ago. Brandon received his doctorate of veterinary medicine in 2012 from the University of Minnesota College of Veterinary Medicine. He serves as the quality control veterinarian for select milk producers. In this role, he evaluates large dairy operations and teams management to develop long-range plans to improve areas of weakness and opportunity. He also creates milk quality management programs, provides monitoring systems and diagnostic strategies to identify quality concerns, and evaluates and improves animal welfare on the cooperative's dairy. Brandon is the National Milk Producers Federation representative to the American Veterinary and Medical Association Animal Agriculture Liaison Committee, member of the Progressive Dairy Editorial Advisory Board, member of the Technical Writing Committee for the National Milk Producers Federation Farmers Assuring Responsible Management, member of the Scientific Advisory Board for the Advanced Animal Diagnostics, and also member of the American Association of Bovine Practitioners and their Welfare Committee, and lastly, a member of NMC Board of Directors. Welcome, Brandon, and thanks for putting this together for us today.
Sure, that's quite the introduction, Keith. I wasn't even sure I did all those things, so it's good to hear sometimes, but a little like hearing your own eulogy, I guess, at your own funeral. Welcome, thank everybody for joining today. We're gonna have what I hope is a really interactive talk on production of high quality milk and robotic dairies. Looking forward to giving this talk. Some of you may have heard me do similar ones in the past. And I promise every presentation that I do, I change them. I change my slides. So you may see some stuff that you may have heard or seen in the past, and there'll be some new content in here as well. Please, as we go along, ask questions, ask lots of questions, and I will answer as many of them as I can as I go, and some that we don't either get answered to your satisfaction or just don't address in the presentation, we will make time to get to at the end. I planned to do about 55 minutes of presentation, may run a little bit longer, but I have plenty of time to stay and answer questions. So if you don't have a hard stop somewhere you have to be at the hour mark, we'll just roll over into the next chunk of time a little bit. So with that, I want to start off my presentation, and I think we'd be remiss not to do this, to pay a little bit of gratitude to the dairy farmers. Certainly, coronavirus, COVID-19, has caused a huge impact on everyone globally, but dairy farmers right now, especially here in the US, are really struggling quite a bit. We're seeing stores that can't keep enough milk on the shelves, but that's not because the dairymen are not producing the milk. It's more a factor of we can't keep our plants at capacity due to worker issues, and our distribution can't get product where it needs to be. So farmers are not only having to deal with dumping the product they worked so hard to produce, but also the reality that the futures market and their pay prices don't look very optimistic for the next several periods of time. So certainly we understand that maybe milk quality isn't the top of your mind right now, but eventually we are going to get back to whatever the new normal of dairy production is, and quality is going to be a factor in that going forward. So with that, we're going to jump into the meat of the presentation, why you all came today. And I think to start, I always like to start by saying that while we think of robotic milking as a new technology, the reality is that it isn't quite as new as what we think. And you see two different units here. Robotic milking has been commercially available since the early 90s. And so we're really looking at something that's going on 30 years old, which we have quite a bit of experience with that from the first ones that went out, which is what you see here, to today. and there have been quite a bit of improvements that have been made on it. And yet, while dairies are definitely capable of producing high volumes of very high quality milk in robots, there's still quite a few dairies that also struggle with it. I like to tell my clients and my producers that I work with, I compare robots to what you see here, which is the very earliest VCRs, and if you can think way back, which is even before my time, the Betamax units. When these came out, they were seen as the peak of technology, and it gave you options to do things you never could do before, which is watch whatever you want, whenever you want. And now you not only can you not buy a Betamax, I think you can still buy a VCR, but instead of the $3,800, if you converted to today's money, that the first of these units would have cost you, $50 or $60 will get you one. And even at that price, nobody is buying them anymore. And this is just to say that technology marches on, and that's good news for us when it comes to robotic milking. The new generations of robots that keep coming out are better at what they do. They have more functionality and are streamlined, and just in general are better units than the first ones that I showed just a minute ago. Part of the discussion around milk quality and robotic milking actually has to come all the way back to people. And the first person in that equation is the owner, and why they make the decision to go to robots in the first place. And it's my experience, and if you look at, there's literature on this, you can look up the motivation for farmers to switch to robotic milking. And a lot of it comes back to what I'll characterize as emotional decisions. And some of those, for smaller dairies, are tied to improving your lifestyle. You just don't want to be tied to the barn every day, twice a day or 3 times a day. You want to be able to see your kids grow up and attend family events and be active in the community, all of those things. You want to decrease labor. You're just tired of 14-hour days. And I'll be the first to say I grew up on a dairy. There are much easier ways to make a living, for sure. So it is a lot of work, and justifiably so, that people would want to decrease their labor. And that they know they have to grow their herds, perhaps, but they want to do it with family labor. They're not interested in going out and hiring labor. For larger dairies, the concerns maybe aren't all that different. The pool of available employees that we are seeing come to dairies looking for work, it's certainly far smaller than it used to be. There's not a lot of people coming and looking for work, and the quality, or at least the background of the people that are seeking employment on dairies they have far less experience than they used to, and they have different vision and values, let's say, than a workforce that we dealt with even 10 or 15 years ago. A lot of large dairies then are motivated to make this change just because either they recognize that they're not going to have a pool of labor that's consistently available, or in a lot of cases, they just don't want to manage more people, for sure, but maybe any people. I often hear that people are far more frustrating than cows, and I think that's very true. Cows are the very predictable part of the equation. We know if we do X, we typically get Y, but people are much less predictable. They don't show up for work sometimes. They let you down. They don't follow strict rules or guidelines. So often labor is a big motivator. Lifestyle also is a big motivator to why you make this decision. We need to understand that because it shapes people's thoughts when they go into a robotic milking installation. And often when emotion is behind making the decision, producers have several things that I see happen, or I hear happen. One is that we have an inflated expectation of what the process might be like. We're so eager to make that change, and we envision it being so good that maybe the reality can't match those expectations. And the alternate, obviously, would be that if you have very high expectations, then maybe your plans that you make when you start into a robotic milking facility maybe are a lot less realistic to achieve themselves, where you're willing to budget, say, a much larger increase in milk into the financial equation than maybe you should, just to make it a reality, to make building a robotic installation feasible for you. And so some dairies, I think this is a general curve of technology adaptation, but there are similar curves for things like change management. Where we start off, we're very excited. We're really into this new technology, or we're into the idea that we're going to change. And then we progress down this slope where we get into an area where we're disillusioned. The result doesn't match what we had expected. And most dairies pull out of that slope. They learn as they go. They learn from other dairies. They learn from consultants. They learn just by life experience. And they get to this plateau of productivity that's on the right side of the screen here. And as I said, robotic milk facilities can make very high volumes of good quality milk. That's a known fact. But some dairies still struggle. And so what can we do as consultants, or even if you're a dairy producer on this phone, to avoid getting stuck in this trough, or maybe avoid that trough of disillusionment completely? I put this graph up here. This is from the University of Minnesota. You can look it up, but we said labor is one of the big motivators for why dairymen and dairies choose robotic milking. And this graph shows two things really eloquently, I think. The first is that you cannot fund a robotic milking installation just on the savings of labor alone. It's not possible to do that. Even when you factor in wage growth, you still need improved milk output, milk per cow per day, to break even, or hopefully we do more than break even. Hopefully we have some annual positive income. And so how much additional milk you budget really comes down to what you're comfortable with. If you're going from a 3-time-a-day milking facility into a robot, often the growth in production isn't that big. If you're going from a 2x milk turd into most robots operate at something just under 3 times a day milking per cow per day, then you're probably going to see some milk increase. But how much we budget for definitely factors into the viability long term of a robotic milking installation. And it does shape other decisions that we make relative to management and barn design and ongoing things that we know impact milk quality. I frequently see where dairies get caught up in a lot of this technology in different ways. One is what you see right here, which is a dashboard, and these are very valuable tools. They put information at dairymen's fingertips that we didn't have access to prior to this, and it's up to the minute information as best as we can. It also, there's several factors though that focusing on this type of information can have. One of which is we tend to forget what got us to today, which is our good cow sense. And there is no substitute for having boots on the ground. You can't run a dairy solely by the metrics or solely from behind a computer. There's no substitute for getting out, looking at the cows, observing, watching what the cows tell you, watching what your eyes tell you. And so there has to be time for both of those to happen. So this is best used probably as a supplement and information that you did not have before, but it can also be a distraction, especially when you get lots of different metrics that are available to you, which ones you really pay attention to, and what are they truly telling me, and how do I interpret that? Another management factor that I see and that we can help possibly overcome is that we tend to wait for alarms when it comes to robots. They have alarms for everything. And so the sense then is, if I'm not getting an alarm, then it isn't broken. And the reality is that lots of things can be broken before they generate an alarm. And there are a lot of things we care about that aren't necessarily, even with all the alarms that are available to us, still are not tied to an alarm. And so again, the alarms are meant to supplement and help you find things you wouldn't have seen with normal observation skills. Having a robot, and the tendency is to think that you're going to separate the man from the cow or the man from the job. And the reality is that's not entirely true. There still has to be observation that goes on. There still has to be some connection to that job beyond just looking at a metric or waiting for an alarm to go off. Another thing that I see quite frequently on facilities that have robotic milking is that whether it be a consultant or a veterinarian like myself or the dairy owner, technology is its own barrier to working with milk quality in some cases. either because we don't have the capability to learn how to, say, in this case, use the software, and maybe the screens and outputs aren't necessarily intuitive to us, or not that we don't have the ability to learn it, but that we don't have the ability to admit that we don't know it, or that it's hard for us. And so we can take one look at this and say, okay, it's going to be very hard for me to do this test. I'm just not going to do it because I don't know how to do it. I don't want to learn how to do it. I'm afraid that I might mess something up or do something unintentional. And so I'm just going to avoid it. And again, that's something to be aware of, whether you're a consultant or a dairy producer. Is technology itself a barrier to actually doing the functions that we know lead to good milk quality? Another one that I see very commonly, and this, again, I'm no stranger to this. If you look at a robotic milking installation, particularly on the milking equipment side, the plumbing is incredibly complex, even compared to very large milking parlors. I find it much easier to test a large rotary than I do to test a robotic milking installation. And the reason is just what you're looking at here. You have to be very confident of yourself and have a decent amount of knowledge to be able to figure out what all this plumbing in front of you does, what each valve does, and where the milk is flowing, where the air is flowing, and then just where to install your test equipment. Where should I take my test? And maybe even what is important. So just looking at the equipment and understanding how to actually make the measurements is sometimes daunting. And the reality is that even for dealerships, some of the brands don't provide enough training, or dealerships don't seek out the right training to be able to get their producers to really feel comfortable with the equipment and knowing what they can and can't do, say, as far as maintenance, but also to have the technicians know exactly what tests they're performing, how to take them so that they're consistent, so that one dealership is getting the same result maybe as a consultant would be, and certainly when to intervene. So what types of numbers are going to mean that there's an issue? What types of numbers would we expect, say, when we first commission the system? So that, with the negative things out of the way, or the reasons maybe that we sometimes fail when it comes to milk quality in robots, I want to get to the reasons that we should succeed. And so I'm going to challenge each of you on the webinar today. When you look at what you see in front of you, which is a GIA monobox robotic milker, how is this different from what you see here, which is a tandem or side opener parlor? And then I'm going to also challenge you, what is what you see on the left here, which is a whey jar parlor from back in the 60s and the 70s that maybe, hopefully many of us on the call have experienced testing. How is that different from the two that you see on your right here, which is the receiver group from a GIA, or we'll use colors, a green brand of robots, or a Lely, which we'll use red for them. How are those different? And the answer is that they're really not that different. A parlor is not, that has whey jars and as a side opener, is very similar to a robotic milker. The robotic milker is really just a single stall side opener parlor with a whey jar. They're plumbed very similar. And I'll add that the factors that drive milk quality in robots are not significantly different than they are in conventional parlors. Really, if you think about the physiology of milk letdown and milk release, the cow side of it doesn't change at all. The physics side of milking cows doesn't change at all either. We still use vacuum to dilate the teat and create a gradient for the milk to flow from high pressure to low pressure. And we're also using pulsation to limit the effects of vacuum on the teat. So all of those things are going to be the same. What we tend to do, I think, is forget about the factors that we know lead to quality milk in a conventional milk parlor or say a tie stall barn when we move into robotic milking. And some of that is because we're separated from the experience, and some of it is we look at it as being different, and I don't really see them as that different than a conventional parlor. Of course, the bonus there is you get more data and less labor. I listed here some factors for us to contemplate as we go through this presentation. You might change the order, and that would be fine. You might add or take away things, but the column on the left is factors that I see routinely impacting udder health, and I did put some kind of rank to them, as I said. The column on the right-hand side is bacteria counts, and we'll talk about standard plate count or raw count, or however you might look at that in your particular area, but just total bacteria in the milk, and wash systems and how effective they are as well. So you'll notice high on my list is cow cleanliness and teat cleanliness, and I want to spend some time talking about that in robotic milk installations. This particular video is of the Red brand of robots. They clean with a brush. And I highlight this only to show what happens when we don't make observations of the milking process. When we allow ourselves to be separated as consultants or dairymen, this system is perfectly fine design, but it's not being implemented properly, which is, you can see the brushes are riding too high on the teat. They're going up, they're taking in too much of the udder floor, and they're stalling out. And you don't have to be a genius to know that if the brushes aren't turning, obviously then they're also not cleaning. This is as simple as changing a setting on the robot and saying, I need the brushes to ride a little bit lower on the teat. Excuse me, jump the slide there. Another consideration here is that if we have, this is a green brand here, if we have something that cleans in the cup itself, then we have to understand that if there's a lot of debris on the teat, that debris has to have somewhere to go. And no matter how much we flush, it's probably going to still end up in the inflation. So we might actually get it cleaned off of the teat, but where is it going to end up? And so that's a consideration as well, because if it stays in the inflation, that's going to impact our bacteria counts, and it's certainly going to impact our udder health. Again, not a knock on a brand, but certainly understanding what the teats look like before they get to the robot is a factor. If this were a traditional milking parlor, we would do teat swabs, which is what you see here. And these actually are from a robotic milk dairy, but I want to put a disclaimer here. While you can do teat end swabs to assess teat cleanliness on robotic milk dairies, it comes with significant risk to life and limb. Certainly those are cows that aren't used to being touched and don't really like a human arm either reaching in from behind or in from the front. There's also obviously the risk of the robot arm itself. You really need to make sure you know what you're doing if you're going to do this. And thankfully for us, there are some alternatives. The first one that I want to show is on the right here. This is just looking at the milk filters, and that's not something different from what we would do in a conventional milking parlor. I often advocate with parlor herds that we hang those milk filters and just observe them, look at how much debris is on there, because that debris came from the cows or the environment, of course. And so this is a good way to look at it. Obviously, all of these that you see here are dirty and are too dirty, but we can assess when we make changes, does it get better or does it get worse? If we do maintenance, does it get better or does it get worse? And all of that is an option to us. Here I measure them, but certainly a visual qualitative check is good enough as well. The graph on the left is just from some research, and it shows, again, I don't think this trend is really any different than parlors, but if you send a clean cow to the robot, they're going to milk a clean teat. The robot almost always milks a very clean teat. And the dirtier that teat is that you're sending into the robot, the dirtier the teat is going to be when it's milked. And that shouldn't surprise us. Humans are, again, as I said, much the same. Though we can perhaps use an additional towel to clean a cow, especially in parlors that are turning 5 turns an hour or milking 24 hours a day, the reality that that happens all the time isn't that true. So the cleaner the cows are when they come to the robot, the better chance you're going to be successful, no matter what brand or method you use to clean the teats. This is just another view of looking at the milk filters. Again, I showed measuring them. That's not necessarily the end goal though, because you can see of all these filters, though I said they're all dirty, filter number 2 is by far the most concerning. If we look at that, it's got the most debris on it and quite a bit of garget. And so that would be, if that comes from a specific box, certainly we'd want to check that, and we'd want to look at our cow lists and make changes based on that and monitor it going forward. Very visual check, very quick check. Hopefully we're changing those filters anyway. instead of dropping that into the trash can, just take a look at it first and kind of look for differences when you change management functions or just day-to-day changes. I sometimes will even use this to look at bedding intervals. If I wait a couple days to bed, is my filter get worse? Or if I bed a little more frequently, does my filter sock get cleaner? I never envisioned that I would own a selfie stick in my life, but this is something, if there's a practice tip or a pro tip in this presentation, this is the one. I use this to do a lot of my observation when it comes to robotic milking. Surprisingly enough, a cow isn't that alarmed when an arm comes underneath her while she's milking. She's relatively used to that. I would shy away from using flash photography, but certainly taking pictures is a good alternative to things like teat swabs or doing teat end scoring by actually looking at the cow. Far safer, far less at risk if you can use a cheap phone, and you'll have the pictures that you can show, and the pictures often are more telling to the producer than a lot of other things. So it makes for really good consulting. As a producer, you can utilize this technique yourself, and we can definitely put a monitoring scheme around this and have good data to look at. Again, when we make management changes, did it get better, or are we going the wrong direction? I'm not going to spend a lot of time on facilities. There's quite a few people in the industry that do talk a lot about robotic milk facilities themselves. I do want to highlight what you see here, though, which is we do have some different challenges with robotic milking relative to maintaining the pen, just because the cows are never all out of the pen at one time. And so often we make decisions based on that or based on other reasons that maybe we know are not as good for milk quality. Alley scrapers, of course, can work quite well, but I want to highlight two factors that you see in this picture that are reasons that I see them fail, and we have dirtier cows than we should. The one is just the obvious, which is the amount of manure that's in front of the plow here. Inevitably, cows are going to have to walk through here. The deeper and more liquid the manure is, of course, the more likelihood that we're going to have splash on the bellies and udders and teats of cows. Again, we said that's going to contaminate our possibly our arm or our milking equipment, but also be much harder to remove from the teat when we go to milk that cow. So again, there are ways that we can mitigate this, running them more frequently, making shorter runs, things like that. The other one that I want us to be aware of is maintenance on these facilities. If you look at the top right of the picture, you can see that the wing is not going all the way to the stall curb, and I see this a lot. We had a chain tear, or we had a wing that got bent or is out of shape, and so it doesn't clean right along that curb. The impact of that then is that the cow is going to stand in that right before she steps up in the bed. The foot is going to be wet when the cow lays down, and again, it's going to impact the number of bacteria that animals are exposed to. So this is a game of odds in some ways. It's also going to impact the cow cleanliness. So things to be aware of, even though we maybe have to make some decisions that we don't like, and maybe go with alley scrapers over other alternatives for clearing alleys. That doesn't absolve us from looking and making sure that they're doing the best possible job that they can. I do have a question here relative to what do you recommend for alley scraper frequency? Again, keeping in mind my dairies tend to be larger, I just tell dairies don't even shut them off, just run them continuously. And you'll see the next slide is going to show what I think are even better alternatives to manage what you see not right in this picture. So I just run them as frequently as I possibly can. I know that's going to lead to a little bit more maintenance, but in truth, a few saved cases of mastitis or just some other factors can easily offset that maintenance. This is from a dairy that had a really novel idea, and it's become pretty commonplace now. This alley that you see here, you can see the slot in the middle, that's critical, but also the alley slopes to the middle. And so all of the liquid in this facility drains out to the middle, and then the plow pushes any liquid or semi-solid material down through that trough. And so not only does the plow not carry nearly as much manure in front of it, it also doesn't have the liquid, which is what leads to the splash. This is something that's hard to retrofit, so you have to design the facility with this in mind, but it is a really good way to do alley scrapers. You'll notice the cows in the picture, I wouldn't put them up as poster children for being the cleanest, but if you look at where the manure is, it's typically going to be on the knees and the hocks. That's more a result of the mattress and the conditions on the mattresses you see than it is of the actual alleys. The bellies, especially of the cows that you can see standing, and the udders are quite clean. Let's talk for a second about mattresses, because I do see, obviously, as I said, when we can't get in the pens to maintain them, we tend to make decisions that will allow us not to have to do that. And I said we forget a lot of the knowledge that got us to where we are today, which is we have a plethora of data that says mattresses are less preferable to cows than deep bedding. And so we have to know that when we're making these decisions to put in mattresses, it's really for our convenience and not for the cow. And there's lots of different reasons for that. The other decision that I see going with the decision to install mattresses in our barns is that sometimes mattresses are sold with the idea that they do not need bedding. And that is just categorically false. I've never seen that to be true. You can make mattresses work. There are lots of dairies that do, but you got to keep bedding on it, if for no other reason, for cow comfort and for the hock and knee lesion side of the equation, and just for keeping them dry and keeping cows clean as well. So even if we do decide we're going to go with mattresses, we absolutely need to think about keeping that mattress clean, and we still have to remember that cow comfort impacts the longevity of our herd and impacts the productivity of our herd, and certainly does have ties to milk quality as well. So not that we can't make those decisions, but understand that we're setting ourselves up to that we have to manage that. We can't just leave it be and have a good result. We certainly have to manage that as we go along. Another question, I'm going to get to this later on, and if I don't, please let me know, but filter changes, we did talk a little bit about that. I'm going to cover that later. The other one is, what about flushing with the cows inside? There are definitely barns that can flush in robotic facilities. That's fine. It depends how much water you're going to send down the alleys, slopes, things like that. And obviously then you have to engineer that to start, right? You can't go in and retrofit that. So you got to have the right slope, you got to have the right alley widths, you got to have enough water flow to carry the bedding away, but not so much that it causes a lot of splash to the cows. So it does work. I've worked with dairies that do it, and if you're in a climate that allows for it, certainly that's an option. Keep rolling on. I'll get to some more questions in a little bit. Again, I said mattresses, we have to be cognizant of the cow's fit to the stall, but then also realize that bedding serves another function just besides providing cushion. It also serves to be a little bit of a lubricator so that there's not friction with the cow, but it also does soak up any moisture that does end up in the stalls. And no matter how well we design a free stall, every cow is not going to be the same size. There's going to be some manure or urine that's passed in the bed. Our ability to cope with that is important. Even in a mattress barn, there's still stall grooming that needs to happen. We need to go in, we need to sweep out stalls. And so when you go through and walk this herd, it would be important that you go through with a broom and sweep that wet material out. Hopefully you have a way to go in and put some bedding on that stall. Even if the cows don't get up, I don't think it's much of an issue. You can work around that, and hopefully you can put bedding on there very frequently, because the thing about bedding on mattresses is it doesn't tend to stay in place very long. It tends to end up out in the alley very quickly, which is nice for drying up the alley, but not very good for drying up the area where the cow is going to be laying for most of the day. There's a compromise that can be had, of course. We can have our cake and eat it too, so to speak, where we do put in our mattresses, so we don't have to manage deep bedding, but we still have a way that we can keep a good amount of bedding on the stalls. There's two options that you see here. Both of them use a pipe, but there are other ways that this can be done. I've seen several that are done with rubber belting, stiff rubber belting that's either just bolted to the stall curb, or made into a teardrop shape and put in against the stall curb with some lag bolts or things. And the idea is just that it's going to retain 2 to 3 inches of bedding on this stall, so that there's, again, the lubrication factor, the drying factor, and the cushion factor. On the left, you see that this is sand. When I practiced in Wisconsin, I saw lots of herds that did this. They took older barns that were designed for mattresses, didn't want to jackhammer the stalls out and do a full retrofit. And so they put in a pipe, put sand in the stalls, and had excellent cow comfort in these stalls, even though there's only about 3 to maybe 4 inches at most of sand there. I do recognize that not all barns are equipped to handle sand, but certainly you can do the same thing with manure solids, which is what you see on the right-hand side here as well. While the hock and knee lesions on this cow haven't gone away, that does take some time, and this is a relatively newer installation. What I want you to see is just how clean that cow is. It really helps keep the cows cleaner than if you have mattresses with very little or no bedding on them on any kind of consistent basis. Milkability and teat end health. Again, these are things that if you're milking the cow yourself, you're typically going to see. Are my cows comfortable during milking? What do my teats look like? I want to do just a credit here to Don Anderson, who's a colleague in Canada, does a lot of work with robots, and we collaborate on lots of robot stuff. I put him in there to show that you definitely can do strip yields on robotic dairies. Again, there's a risk that goes with it, and interpreting the data is somewhat harder, perhaps, than it is in a conventional facility. Obviously, if the cows stand to have their teats stripped, I can tell the cows are very comfortable. It's the alternate that gets a lot harder. If they're kicking at me, I don't know if that's because of the milking experience or if it's something else, but it is still valuable to know how dry we're milking cows. And I think there are different ways you can achieve that, creative ways you can achieve that, but you can do the traditional tests in a robot dairy. Just understand that there are risks that go with it. Certainly, though, there are easy things that if we're just paying a little bit of attention and we're just observing the cows when they milk at all, we're going to pick up on. Again, it doesn't take a lot of knowledge to know that this teat on the right looks really dry and extremely chapped. And so we know we have a teat condition issue. We know that that is going to cause the skin to be able to grow and harbor more bacteria. We also know it's going to make it much, much harder for teat cleaning to occur in any kind of efficient manner. And so this is an issue that we both, it's easy to recognize if we're willing to look, and it's easy to correct if we care to take action. There's an old adage I was taught in vet school that you're going to miss more for not looking than not knowing, and I think that is absolutely true on robots. We have to make it a point to look more and ask more questions and do more things, and not focus on what we don't know or what we don't feel comfortable with. Even if you don't know the answer to what you see or what you observe, just the fact that you observe that it's not right or it seems out of place may be enough to trigger the change that is going to make the dairy a lot more successful. Just another call out here, and in the corner of that right-hand picture, you can notice there's a lot of manure on these inflations and the inflation heads themselves, and we'll get into those checks in a little bit. But obviously that came from somewhere. That's coming off of cows, either their legs or on their udder or belly or somewhere on that cow, and it is going to impact our bacteria counts, of course, as well, and possibly our risk for new mastitis infections. Some other pictures of teats. Again, you don't necessarily have to touch the teat to do teat end scores. You don't have to, certainly please don't lean over with your head and look at the teat. That would not be a good way to have a long lifespan in a robot dairy. Use the camera to take those pictures, or use some other way to get a look at those teats. I think that's just fine. Obviously, again, we can see these teats are in poor shape. That might just be a function of liner choice or milking equipment settings, but you recognizing that there is a lot of teat end hyperkeratosis might just be the thing that triggers them to look a little deeper into other areas. You may not know what other liners are available for that robot, but if you see the picture on the right and you can say a lot of the teats are discolored at the teat base, which I apologize, this picture didn't show up very well, but hopefully you can see that there's a blue band towards the top of that teat. that's a potential indicator that either we have significant over milking, or at least that we're running a high mouthpiece chamber vacuum, and maybe we should explore end of milk settings or liner fit relative to the herd. While we're on the topic of liner fit, I think there's this, it's less so than it used to be, but there's an idea out there that robots are somehow just plug and play, that we can wheel them in the door, plunk them down, plug them into an outlet, put a few band clamps on a hose that supplies vacuum, and we're milking cows. And the reality is that it's not that way at all. Every herd has different goals. Every herd has a little bit different genetics and different animals. And if you look at a milking parlor as a comparison, which, as I said, I think we should, liner fit is one of the biggest factors relative to milkability and comfort of cows during milking, and just success with milk harvest in general. And that does not go away when you're in a robotic herd. It helps to know what the size of the teats are that you're going to be milking, and what the size of the liner is that you're going to put them in. And the reality is, a lot of the liners that we see available in the North American market are based on what I'll call European preferences, which is a very large bore liner with a very big mouthpiece chamber area and a small mouthpiece opening. And some of them, you can put 2 thumbs inside that liner and wiggle them around. And a lot of the herds I deal with are very young. They're startup robot dairies where we're milking a lot of first calf heifers. They tend to have very small teats. And if you want a recipe for uncomfortable milking, put very small teats in that very big liner. You just don't get very effective massage or overpressure from that liner when there's a mismatch between the size of the teat and the size of the liner that you're using. Keep in mind that even if you're doing feed first or milk first or guided cow flow type systems, you're still reliant on the cow to want to come and be milked far more than you are in a milking parlor setting. And so we need to do everything that we can to make that as enjoyable an experience as possible, because cows do have quite long memories. If you insult them, it's going to impact your visits to the robot. And I do see dairies, or have looked at dairies, where it was very obvious that the comfort during milking and the milking experience had an impact on our visits. So don't discount that. If you just can't get the visits that you think you should be having, make sure you're looking at that milkability and that you have the right milking settings and equipment to really achieve your goals with your herd of cows, not what somebody else thinks you should use for their herd of cows. I do like a lot of liner observation. You can see the liners here on the left are, they've got a warp on them. One side is raised while one side is lowered, so it's got a kind of a wave in it. We don't necessarily hear the squawks that this creates like you would in say a parallel parlor, but the results are the same. You may not have the unit fall off the cow because there's no weight of a claw bowl hanging beneath that liner, but you still do have changes in your milking vacuum that are a result of it. At very least, it's going to slow your milking down quite a bit. And so this is a great example of where, yes, the indicator may not say it's time to change liners, but the sum of the functions you've been doing with that liner, this particular one is showing too much wear. And this also is then an area where you can say, if I change liners and my parameters get a lot better, my milking times get a little bit better, if my number of long milking quarters gets better, certainly that is an indicator that maybe just because it says you can get 10,000 cow milkings, maybe you're better off trying for something a little less than that. Because in your particular instance, the way that you're using them on your cows, 10,000 may not be the ideal recommendation. I put the picture right up as a little bit of just a warning. I'll say they're less so than there used to be, but quite a few people who have talked about putting liners that maybe aren't designed to fit in what I'll call the original equipment manufacturer shells. So they're fitting a different liner choice into a shell that it wasn't created for. That can work pretty well, but understand that it's not a solution that's designed to work together. So things like liner stretch are not necessarily easy to predict. And in those particular scenarios, you may find that you don't get the liner life just because it isn't exactly fitted to how you're trying to use that liner. I always try and use the manufacturer's equipment or something that's designed for that particular solution when I can. Again, there's quite a few more options out there in the North American market, and my understanding is what I'll lump as rest of world has even more options than we do here in the US. We're the most restrictive, and even we have multiple different options from each of the major manufacturers. A photo credit here to Dr. David Reed, although I don't have it listed. These are just Lely shells, and I use that to point out that even among a brand, there are multiple different shells that you can run into. These are 3 different ones, and so you can't just make broad recommendations, and you shouldn't necessarily just believe that your neighbor who also has a Lely robot and says this liner is great. You can't just necessarily go and put that onto your the equipment you already have. There may be other considerations and changes that go along with that. So that's not to talk you out of making liner changes. That's to talk you into asking all the right questions and making all the right considerations before you go ahead and do it. A lot of daily maintenance that goes with robots. I'm not going to dwell on it too much. In this particular scenario, this is a dealer valve classic. This backstop for the inflations when they drag across here. Obviously, if you're not cleaning that, there's milk and drainage that's going to be on it. That's all going to be laden with bacteria. That means every time your liner hits it, it's going to get recovered with bacteria. The other point I want to make too is that we shouldn't forget about things like unit alignment just because we're in a robot milking situation. Unit alignment still matters. Quarters that don't milk out fast enough or in the same speed as the others, they matter. So you can adjust these hose lengths to get better unit alignment. It's not required that you never adjust the hose length. You can do that here in this particular adaptation and perhaps improve your unit alignment. Maintenance, this is by far not a complete list, but things I like to do every day. I like to observe 2 complete milking events per robot per day. Certainly cleaning around the box, the exit, the waiting area, that's critical. And don't forget about foot baths and selection gates. Those are all areas where manure can build up and we can see that splash happen. I like to hose down and I put scrub with a question mark. There are definitely components you cannot and should not scrub, like lasers and cameras, but there are a lot of others that you can scrub. And I equate this back to what you did when you were in a tie stall barn. We carried those units out of the barn, we took them into the milk house, we scrubbed them completely. And we shouldn't forget about what made us successful there. When we go to this technology, there's still cleaning that needs to happen. Biofilms are real, so even things that look clean may not necessarily be sanitary, so we have to be aware of that as well. This is a good chance to observe the condition of all of those parts I listed there for you. I do like to check. I'll particularly call out the liner vents. Those are critical. We do have long runs of hose. They're engineered to be a correct size. It may be possible for the cow to still get milked if they're partially obstructed. But again, we're looking at how can we be efficient? How can we do consistent job of milking cows correctly? And so making sure those vents are open at least every day, but hopefully multiple times a day would be ideal. And then we did have a question earlier about milk filters. I think 8 hours is kind of a minimum, to be honest with you. I can't think of any 3-time-a-day milking barns that wouldn't change at least every 8 hours. And even a lot of 2X barns, a lot of those aren't going to milk 24 hours a day. And if they do, they're going to change at intervals even less than that. If you think about a parlor, a lot of parlors I work with, they're going to change filters as much as every pen, but maybe every other pen, which works out to about every 1 to 2 hours. We know the milk filter is a great media to grow bacteria on. We know the temperatures are right, the food is there, the moisture is there. So leaving it in place, every drop of milk we force through it, there's going to be exponential bacteria growth on it. Whatever milk bacteria or debris is in the milk is going to be cultured on that sock, and then we're going to push other milk through it. So the longer you let that in place, I think it's not doing you any favors. again, you're balancing the cost of the additional filters with what's the impact on milk quality. And I certainly think you can justify every 8 hours. I like to look at other things. Downtime with robots is not an option wherever we can avoid it. So checking things like ropes is important. This is the thing that's going to get you a phone call in the middle of the night or get you a page in the middle of the night, because this is inevitably going to break at 3 in the morning and you're going to have to come in and fix it, or you're not going to be milking any cows. So being proactive with maintenance instead of waiting for the alarms to go off definitely pays. This is another example with brushes. These brushes were not at the interval to be changed, but when you look at them, just a little bit of observation will tell you it does not matter what kind of sanitizer or germicide you're spraying on these brushes. There's so much organic material and debris in them that you're going to inevitably not be able to kill the bacteria that reside there. And chances are good that you're going to be putting bacteria onto teats, or certainly not at minimum be cleaning with much efficiency. The other observation I want to point out here, and I do see this a lot on barns that clean with brushes, I can tell exactly where the teat resides on these brushes when they're cleaning, and it's right at the very tip of the brush. The centering of the teat within the brushes is not happening. So in the picture in the middle, you can see how frayed the brushes are at one end, while the rest of the brush looks perfectly new. In the other view of it, you can see the bristles are actually missing at the end and look new throughout the rest of the brush. So again, this is just simply a setting on the robot. You change a little bit of the teat orientation within the brushes, and you're going to get a better job of cleaning. You're also going to get a better lifespan on your equipment. Another example, the same thing. I can tell exactly where the teats are being cleaned. The left end of these brushes is completely frayed. This is not at the interval to change, but guaranteed they're not cleaning very well. And you could pick this up on milk filters. We actually did. If you move to the middle of the brush, they look brand new. So make sure that you're looking at the little stuff, because the little details do matter when it comes to milk quality. One of the greatest assets of robots is that they're really, really consistent. And I love that. And so if we can help them be even more consistent, that is an asset to milk quality, and an asset that people, frankly, are going to struggle with. Unless you milk your own cows every day and never take a vacation, it's very difficult to even approach the consistency that a robot can have. So help it do its job, and make sure you're looking at all the components, even if it says they should have plenty of life left in them. As I said earlier, managing bacteria counts and new intramammary infections comes down to playing the numbers. And when I say numbers, I mean bacteria count numbers. And in that role, I've emphasized it a little bit before, but cleanliness is truly next to godliness. If the milking equipment isn't clean, if the area around the milking equipment isn't clean, it's going to be very difficult to get consistently high quality milk. And so I already showed you the picture in the middle. The picture at left, obviously, it's not hard to tell a lot of debris and manure in those hoses and on those units. Not as much on the units as in the hoses, but this causes maintenance issues. It causes decreased life, but again, it's certainly going to impact milk quality. The picture on the right, that doesn't impact the milk quality of saleable milk, but certainly the health and welfare of the calves we're feeding does make a difference. This is designed to collect milk for feeding to calves. Obviously, visually not clean, and that's the first step to sanitary. If you're not visually clean, you're certainly not sanitary. So again, basic checks. You don't need a lot of knowledge. You don't even need to know the computer interface to make these checks. And for dairymen, it's worth investing your time in this stuff every day to maintain that cleanliness. I check connections when I'm on the facilities. So this is just a blue example. The right-hand side is where the milk and wash solution flows through. The left-hand side would be my pulsation side. Very clearly, I don't have to have equipment to graph pulsators to know that probably this is not going to be a very good functional pulsator. And certainly if it is, the risk of a chunk of this breaking off and seating on the diaphragm is very real. So I can flag an issue and not even have to have any fancy test equipment, and don't really have to know that much about the computer software to do a basic check like this. Talk a little bit about testing. We had a great discussion at the annual NMC meeting this year about it. If anybody on the call is not an NMC member or hasn't been to an annual meeting, I really recommend both. Really valuable experiences. At our meeting this year, we had a short course devoted completely to robotic milking. And one of the discussion points was that was brought up is it's hard to get excited about what we call static testing of robotic milkers. So pump capacities, effective reserves, things like that. And I agree with it, although I also agree that in case there are cases where it should be on the table. And the reality is you can do all the same tests that you would do with the parlor on a robotic milker. The way I look at this, I use the dynamic tests that, so if you look at the form, the dynamic tests would be pulsation graphed under load or with plugs. I use peak flow claw vacuums, which in this case is really just in the liner stem. And then I'm also going to use things like mouthpiece chamber vacuum. And I'm going to use those along with my system vacuum stability during milking to interpret if I need to go further and I need to dissect that and find the root cause of why there's an issue with that dynamic testing. So as an example, I'll use a medical example. You typically don't jump to doing an EKG on a patient, right? You're going to measure their blood pressure or listen to their heart first. If you flag an issue there, then that's the place to go and run a diagnostic that's going to tell you why there's an issue. And so that would be where you'd run the EKG, or in this example, where you'd go in and measure the pump capacity. Keep in mind that many of these robots have functions that use significant amounts of vacuum for things other than milking cows. And quite a few of them don't have very much vacuum capacity, meaning that their actual vacuum capacities and plumbing sizes are not conducive to high airflows. So it is worth doing these tests, even if all you do is flag that there's an issue and flag that there needs to be more testing done. I think, again, we miss far more for not looking than for not knowing. So just don't let not looking be the reason that one of your clients or your own dairy was not able to succeed. I use the Videa units you saw in the last picture. There's a couple of reasons for that, and this isn't an advertisement, but it's a remote sensing unit, meaning that I don't have to stay with the unit. There's advantages to that. One is probably the biggest one for me is if I stand there with my test equipment, I impact that milking quite a bit, whether it be from the cow coming into the unit or just her knowing that I'm there at the time she's milking. So it does change cow behaviors. It does, I think, in some way alter the results I get. And I prefer to be able to place one of these units and leave it and come back and get the data. And I'll say the other benefit of this is it allows me to test more units in a set amount of time. You can do it the other way though. This is an old SA2 and you can see that they're collecting the same data here. I just recommend you take the unit with you when you're done testing both between cows, because these units, a lot of them, they get wet or they get knocked down and they do attract a lot of attention from cows. They often take damage that is irreparable. So taking the vacuum stability, this is how I do it. There are other ways. Depending on system plumbing, you might be able to do it in a common line, but I do it right above the receiver. This is just the GS sampler for their meter. It fits pretty well on their own robot receiver. It also fits pretty well in between the connection, the vacuum supply on the Lele. And I'll just place my Videa unit there and I can do a long-term vacuum graph there to see what my stability looks like. Again, I'll interpret this and see if I need to go and look further at regulators, and keep in mind, these are very complex vacuum regulation systems that often use a combination of physical manual regulators and a variable speed control on the pump. And so there are lots of different issues you could encounter. I'm not as concerned that I can figure out exactly which one we're having. I'm more concerned with the fact that I can flag when vacuum stability is poor, because the fact that I'm milking in a robot doesn't mean that vacuum stability is any less important than it would be in a parlor. And I think most of us would recognize that it's very important. It's one of the more important milking equipment things in a parlor. When you do that, you find all kinds of things and learning opportunities. So this would be of a dealer valve classic. Just a graph to illustrate. I wasn't aware that they drop the vacuum down from whatever your milking vacuum is. They drop it down in quite a bit lower before they pull the units off. Just things that you learn. If you don't look, you're never going to figure that out. And this is another one. This is a receiver vacuum like we just talked about. I think we'd all agree that is not stable enough vacuum there. Yes, it's only one point in time on there, but it's at a critical point in time after we've just connected our cups to that particular animal. And so it's something maybe worth seeing how often it happens, and also maybe looking into why it happens. Okay, I know we're running short on time. I just want to focus a little bit on key performance indicators. We're not going to spend much time on this, but I do think it's worth a little discussion. I showed you the dashboards that we have available to us before. There is literally just a plethora of information that dairies have access to when you go to robotic milking, and things that we never dreamed about. So much so to the point that it's almost a data overload. Which ones do we pay attention to? Which ones do we monitor? And which ones are important to achieving our end mission? And even now you can get a lot of this data on your phone when you're away from the dairy. Again, I try hard not to let this, I like it to supplement what I see and what we observe and what we know. I don't like it to be our primary source of management input. I like it as a supplement, not as we base most of our decisions off of the metrics and the numbers. In general, I'm not a huge fan of benchmarking, and those of you who've talked with me in the past, I'm sure you heard that. I think benchmarking tends to be abused quite a bit, and I'll say misused maybe more frequently, and so it's often done poorly. And a good example here is that you cannot necessarily compare across brands and facilities when it comes to robots. There are different designs in facility where metrics might be quite a bit different. And the fact that one dairy is doing better may not be a reality of the actual result of management that you're putting in. Also across brands, they don't define things like box time the same. So box time in your dealer valve neighbor may not be the same as box time in your Lely barn or your Gia barn. I look at benchmarking a little bit like building a breeding program, in that I don't focus typically on one single metric. Especially at the expense of all the others. And the ones that I do choose to focus on have to have some kind of economic importance, meaning they have to be tied back to economic things that actually make the dairy more viable. And because of all that, the benchmarks that you choose need to have some tie to your business philosophy. So knowing what your milk market is, knowing how you plan to feed your cattle or your management scheme, and just knowing what type of animals that you have, what their genetics are and ages and things like that, may change what you choose to look at and what might be relevant to you or may not be relevant to my herd. Just a common one that I think we all probably should be looking at. Production per box per day is probably the most universal metric that I look at. It's got a very clear economic tie. There's a sunk fixed cost in that robot, whether that be just the initial cost of ownership, or you look at the cost of maintenance, or just even running it every day, the electric, the hot water, the chemical. And so defraying that over more pounds of milk is good. And so a common number thrown out is 5,400 pounds. I think that's going to change in the future, and I think it's going to change upward in the future. We'll talk about that here real quick. But also I keep in mind, I don't just look at pounds of milk, because a lot of milk markets, especially some of my clients, are very much a component market. And so actual pounds of fat harvested per day sometimes means more than the actual pounds of milk. I'll give you examples of mistakes I see that we should never do. I never let something like visits per cow per day trump things like production out the door. So if I'm getting 2.7 visits per cow per day, but I'm hitting all my production benchmarks, I'm not going to let someone tell the dairies I work with that they should be, that that's somehow wrong. That consequently, the other way, if we're 3.3 visits per day, but we can't hit our production benchmarks, that's not irrelevant, right? It's not irrelevant. We might be hitting one metric, but the visits per cow per day doesn't pay my bills. So I would much rather hit the production benchmark and not be exactly where they tell me I need to be for visits. I'll say fetch cows is another one. I hear a lot of dairies brag about not having any fetch cows. I don't think every fetch cow is bad. You know, some of those cows are cows that you need to find. They might be a little bit lame, or they might have some kind of other issue that we need to be aware of. And so the fact that you had to go catch a fetch cow isn't necessarily always a bad thing. I won't say it's always a good thing either, but also keep in mind that the design you choose, whether it's free flow or guided flow, and then within either of those designs, what kind of feeding program you put together will affect both of those. So again, you can't necessarily compare to another dairy about fetch cows, or you definitely shouldn't. I want to introduce the idea of a time budget for a robot, like what we think about a time budget for our cows. And I want us to think about what we do with those 1,440 minutes a day that we have. How much of that is actually spent doing what pays the bills, which is milking cows, and how much is spent on other functions, and thinking about efficiency. This idea that a box can only milk 60 cows, I think we're going to see that challenged, and I think we're going to see that become no longer the standard very quickly here. And this piece of research by Dr. Doug Reineman, who's a name that we're probably all familiar with, and others, it really shows that in a, I think, a stunning way. The milk per box per day, two factors really affect that. The total box time, so how long a cow milking takes from the time a cow enters that box to the time she's finished, and then the flow characteristics of milk. So how quickly are we able to harvest that milk accounted for 99% of the variation in milk per box per day. So making more time available to milk cows, and what percent of that 1,440 minutes is available to milk a cow has the biggest impact by far, but then also improving the milking characteristics. Between those two, you can really move those numbers quite higher. And you'll see on the bottom chart here, some theoretical numbers based on just changing the permission limit, which is how much expected milk must a cow have before we'll actually let her be milked. And so you're looking at numbers now that are quite a bit higher than what we used to think about in the 70s and even 80s and up. I don't know anybody in that 100 number yet, but I do know dairies that are pushing over 70 and still getting good results with that. So I think 60 is a glass ceiling, and I think that's going to be broken very routinely, very quickly. One of the other ways that you can have more box time, of course, is put in guided cow traffic. And I won't tell you which one I'm for, free or guided. I think both can work in good management situations. Guided cow traffic, of course, allows us not to have refusals as nearly as often, because the cow will get sorted away from the robots by the sort gate, the direction gate, if she's not ready to be milked. Otherwise, if you have free flow, the robot has to do that function. So more of our time is devoted to milking. The downside, of course, of these systems then is that you know, we are telling the cow what to do, and we do have data to say that it changes how cows eat and how many times a day they eat. And of course, if you're putting a new heifer into this facility, how long is it going to take her to be able to figure out how to navigate those gates? So with that, I'll come to a close. I know I'm over time, but did want to work some of those things in on the benchmarking for you. I know we have a lot of questions, so let's get to some of those. What kind of bedding do I recommend? Obviously, the data says sand is the best. If I could have sand bedding, and It does work with robots. I worked with multiple herds that use sand. Works very well. There are some maintenance considerations that you might have with it. You may choose chains over ropes or things like that, but definitely does work. If you have a new facility and you can set yourself up for that, definitely that would be my first choice. My second choice would be, it's kind of a draw between maybe straw or shavings, and manure solids can be very good if it's managed properly and is dry enough. So any of that's possible. Whatever you have that you can keep on mattresses and you can apply relatively frequently, I think is going to be the best. They all can work. And I tell my producers, it's how intensely do you want to manage? I think sand, you can get away with a little bit less management intensity. Manure solids, of course, has the most management intensity because it's a somewhat variable product that, though it might be bedding today when we put it in, there's a steady progression from bedding to manure, like back to manure. So we have to be able to manage that. What depth would I recommend to stop manure coming over into the bedding cubicle? I think that the question here is how much of a step would I be willing to have to get into the stall? If I'm wrong on that, please let me know. You would be amazed what a cow is willing to step up into. So when we've had to do retrofits where we have to go in and put in a retainer, cows to have a more comfortable bed, a lot of times cows are willing to make a bigger step than you would think. And again, I'll tie this back to conventional parlors. If you've ever seen some of the tie stall barn retrofit parlors where we ask the cows to step up on a podium so that we don't have to bend over to milk that cow, they will do amazing things when asked if they're trained and well motivated. And comfort and dry actually are huge motivators for stalls. So if you're transitioning to something that has a lot of humidity and moisture on it, a mattress with no bedding, dry bedding and enough of it to provide a good cushion, they will step up quite a bit. If you're alluding to what would be the least amount of depth that I think would be okay, I don't have a good answer to that. Some of it depends how you want to clean your manure. If you're going to do flush, you need a certain amount of depth because you don't want it to run up into the bed. Alley scrapers would be the same way, I guess. It would depend how much you're going to move in front of that plow, but I'm not aware of a minimum height requirement. But maximum height, cows are amazing creatures and they'll manage a lot of different things. The next question is about tail docking. Have you ever documented a robot trying to attach to a tail? It does happen. The way we avoid that now is we trim tails, and really that has been reasonably effective and not really created an issue for our herds. I'll say most of the herds that I work with have not tail docked for quite a long time, partially because we realized we didn't need to, partially because things like stall design made it so we didn't have really dirty cows. And also partially because we saw that it was coming, and so we knew we had to adapt to not having that. So keeping tails trimmed, I think, in robots is a function that you should be willing to commit labor to, and you should account for. And the same would be true of either udder singeing or clipping hair on udders. You really, if you want to have the most efficient connections, you gotta keep those udder hair managed. And that also does help with the actual cleanliness of the udder, especially when you're using things like shavings or sawdust bedding that easily stick to that udder hair. What do I recommend for dairies that pasture their herd when it comes to robotic milking and milk quality? I think all the same principles apply. It's just the place where you're doing the milking is somewhat different. And I'll be frank and upfront here. I don't work with any dairies that pasture and use robotic milking. I think there is a lot of information out there if you want to look it up. And I have my email address up here. If you want to contact me directly, I can get you in touch with people who are in markets where they do a lot more grazing and can probably give you some better insight than what I have. This question is, what do you think about dry fiber manure on top of a mattress? If it's truly dry, I think it makes very good bedding. Again, keep in mind that there's always a progression from dry fiber to wet manure, but it's fluffy, it's good bedding material, requires more management than sand in that keeping it wet and clean is even more critical than it is with sand, but can be very good bedding. And if that's what I had, a lot of my dairies bed on manure solids. And again, when we can get it dry and we can manage it where we can have enough throughout the year and not use stuff that's partially been through a compost cycle, we generally do pretty well. Keep moving here. What is my experience with compost pack barns with robotic milking? Does it affect visit behavior or milk quality? Certainly can, but in all the same ways that we talked about before. If there is a manure buildup on the cows, if we're not managing our pack properly, certainly that impacts milk quality and can create plenty of issues for us. And again, that wouldn't be different than a regular conventional parlor. It's how you manage that pack when you add additional bedding, how you till it, how frequently you empty it, ventilation in those barns, that all becomes critical. Cow entrances from the feed lane become critical. Water source areas become critical. So yes, I do have experience with it, and really the cleanliness is the biggest factor. It can be very comfortable for cows, can do a really good job. We just have to make sure we're managing it appropriately, just like any other bedding. How many cows in a herd should you do strip yields on in a robot? Is the same 20% rule as conventional. I use all the same standards for robotic milking testing as I do for conventional, unless I ever have a reason to justify it being different. And it's actually, there are very few instances where you could justify a difference. So I try to get as many as I can. But the reality is, in a robot, if you've ever done any, you are not going to get 20% because it's just not going to be easy for you to do it. The cows aren't going to make it easy. There's going to be some risk, so you're going to assess a couple and really try and get a feel for that. I will tend to do it more frequently and less cows than less frequently and the 20% at a time. I don't know that that's right, but that's just what I choose to do. And quite honestly, I don't want to stand there for 20% of the milkings because that really is going to impact the cow flow. So I'm going to collect a few and get a good idea of where I'm at and if it's similar to what I've done in the past versus enough to be statistically sure that there's an issue or not. Next question is, how do I feel about sorting cows right after milking is complete to do strip yields in the headlocks? I have not done it. I know we do it for treatments, we do it for dry offs, we do it for things like that. My concern would be there is a definite time limit on how long you can wait after the unit has detached before doing the strip yield. And because there's always, there's a little bit of residual oxytocin effect. And so there'll be continuous small amounts of milk letdown as you go from every second from after the unit detaches. So there's really a time window in there to get it. I'm not sure I would lock cows just to do strip yields. I would try and get the data in other ways. The other way that I use most frequently, and I didn't directly allude to this, is I use the amount of over milking time or high mouthpiece vacuum time on my Vidia units to look at how much over milking I have. It's much less invasive to get than doing the strip yields, and it gives me a lot of data because I get a lot of cows, more than the 20%, and it gives me good numbers to base it off of. So I use that whenever I can. How do you get more incidents of hyperkeratosis in robotic systems than conventional? I hope I didn't say that you get more than in conventional. I don't have data to support that. What I do have data to support is that you still get it in robotic milking systems, just like you do in conventional. And you get it the same ways that you get it in a conventional parlor. Over milking when you don't match your vacuum settings or your pulsation settings to the liner choice, and when you don't match your liner choice to the teats of your cows. Those are the main ways that I see. There is a concept in robot milking that says, okay, we quarter milk, so over milking doesn't matter. I've not found that to be true. I still think we should be trying to get units off of cows as quickly as possible, and the cows tend to support that for me. But again, draw your own conclusions there, because I don't have a lot of data on robots to show that. But again, vacuum is an unnormal condition for all living tissue, and so removing that unnormal condition is generally better for skin and teat end health. Question specific to, it sounds like a herd. Many of our Holstein heifers have very short teats, and it seems like the teat end is above the collapse point of the inflation, resulting in very poor massage. What recommendations do you have with regard to best shell and liner for short teats? Superb question. I see this time and time again. The European style liners that I talked about tend to have a very deep mouthpiece. What that means is if you measure from the lip of the mouthpiece down to where the barrel of the liner, the tube part of the liner starts, it's very deep. And the liner collapses from the middle out to the ends, and it doesn't collapse all the way to the end. There's no liner that's thin enough that has low enough mounting resistance to go all the way to the end of the teat, or to the end of the liner barrel. And so there's a minimum amount of distance you have to penetrate into the liner to get a massage. And in the absence of massage, you get a lot of fluid buildup. So you'll see red teats, you'll see very firm teats when they come off, and you'll see uncomfortable cows, and sometimes even blue or purple, depending on the extent of that buildup. The best thing you can do is find a liner that has a shallow mouthpiece to it, and something similar to what you would milk cows with in a conventional dairy. So if you look at a lot of the liners that are out there, they've got a shallow mouthpiece and allow for less penetration in the barrel to still get massage. And that's really what you need to think about. The other thing to consider is just the actual size of the barrel, how big around it is versus the shape of the teat, and the size of the teat, because you actually have to make contact with the teat in order to provide massage. And if you've got a lot of airspace around the teat, not only are you going to have high mouthpiece chamber vacuum, but you're not going to get very good pressure on that teat, which is what we use. We need that pressure right basically on the corner of the teat ends, down towards the tip, because you don't compress the top part of the barrel, only the end of the teat. You need that pressure to be able to relieve the congestion of blood and lymph that builds up in those ends. So find something that's more conventional, that has a shallow mouthpiece and has a barrel more suitable to whatever size and diameter of teat you have on your heifers. Hope that helped. If you want specifics, email me offline and we can talk about it. How often should teat brushes be targeted to be changed as a general rule? Does this vary by brand? Yes, it varies by brand, and the makers have their own recommendations, and I look at them and let them tell me. There are instances where they can run longer, which don't interpret that as I'm changing them too frequently. But there are also instances where we need to change them more frequently, and a one-size-fits-all idea for when to change these things isn't really that accurate either, because we do different things with them. We milk different teats. We do different things with prep, perhaps, and so just a milkings counter isn't the best way to think about maintenance. Is there a practical tip for keeping plumbing and buckets clean in the robot if using the system to collect milk for feed calves or for feeding to calves? You know, I think it depends on your definition of practical. I do it the same as I do buckets in parlors. I think there are automatic washers and things that you can hook up. I don't have anybody who's got them, but I've heard of different things you can do. I really just go back to manual scrubbing with detergent, and you got to do that every time. So that has to be a once-a-day task. It doesn't take a lot of time, and you can check how effective you are with it too. Things like ATP swabs that we use in dairy plants are decent ways to check some of these things to see if they're sanitary. So those are easiest to clean with just manual cleaning, manual detergent. I use the same types of chemicals that I use to clean a conventional pipeline. So a caustic for the milk fat, a chlorine for the protein, and to do some sanitizing, and then follow with an acid for milkstone. And hot water, of course, is critical there too, because you got to turn that milk fat into something that's soluble that you can get away. So hot water is key, and that's true on the robots too. If you're going to use a common water source for cleaning robots, having just oodles and oodles of hot water and hopefully soft water makes a huge difference with system CIP sanitation on robotic milkers. Still got a lot of questions. I hope it's not running too long for you guys, but the follow-up comment to that was, my experience is robots do a poor job of auto cleaning this area. I agree, and that's why I say we just have to commit to manually scrubbing it. I'm not aware of any design functions that really do a good job of automatically cleaning it. So that's one thing. We know what the impact is of bacteria in milk, even if we pasteurize it. And a lot of smaller farms are not going to be pasteurizing this milk. So we really got to make sure we're clean about it. Maximum vacuum that the teat should be exposed to during the prep phase of the GIA system. I'm not sure I know the answer to that question, to be fair. That's one where we can look it up in the manual, or a lot of times, quite honestly, the manufacturers, if you go and ask questions, they are reasonably open to talking to you about it. And sometimes they're willing to admit that they don't know. So I would say I don't have an answer. I don't know that there's great data out there to tell us what the maximum is. There is data to say what it typically runs. And as I said, you can look that up in the manual. In the US, they have, all the manufacturers have to have a cleaning protocol that they submit, and that outlines several of those functions, but really the manual is your source of that information. And then secondarily would be looking to the dealerships and asking those type of questions. Likely it's a question they've never been asked, and at the very least, it's going to make them go back and ask some more questions of the people who support them, and everybody learns from that. So not afraid to say I don't know the answer there. Keith is on this call from GIA, and perhaps he knows something. We can circle back to that. Keith, do you want to jump in there? Do you know what the maximum should be?
Unmuted now. So basically they're using Stimipulse and rapidly moving the liner when they're going through that process. So just like any other Stimipulse basically rapidly moves the liner back and forth. So it'll go from the system vacuum down to like nothing and back and forth. So technically it really should be close to system vacuum as far as the max, but we definitely have people on our AMS side that can look further into that as well. But technically being Stimipulse, it should be, the max should be system vacuum.
And that's my experience. You have very little milk flow during that period. So yes, if you understand what he's saying, they pulse the liner just really rapidly, and that accounts for a lot of the cleaning. But really, you're going to be operating at just about whatever your system vacuum is going to be. At what days in milk do you like to see milk access restricted? I do not do it by days in milk. We're doing this by predicted milk production. So we're saying if you're going to give us X pounds of milk or X kilograms, if you're in the rest of the world, you're allowed to milk. If you're not, then you're not going to be milked. So I'm not really restricting it. I know dairies that do, but I work with a lot of herds that there's herds that have high day in milk cows that are making quite a bit of milk yet. And I don't want to restrict them necessarily. I want to allow them to milk at their natural interval based on whatever their udder pressure is going to be. And really that comes down to what kind of milk flow am I expected to get, because low production cows don't necessarily take a lot less time to milk. So we have a sunk cost in how long it takes us to prep that cow. And so we want to dilute that over harvesting as much milk in as short a time as possible. Because we're not harvesting milk during the time we're prepping cows, obviously. So if we're looking to just improve that efficiency, we want to harvest more pounds per visit. Every time we do that prep, the higher the flow rates we can get for the time that unit is attached, the better off we're going to be. So I don't advocate doing it based on days in milk. I advocate doing it based on predicted milk yield at that visit. Fresh manure versus compost. Good question. There's some different rules here. If you can manage compost well, and you're in a scenario where you can make it be consistent, and you're actually going to do a compost process, and you're going to monitor it and take temps and turn it and do all of those things, compost can be very good. If you're going to shortchange that and just pile it and let it sit somewhere and then eventually come back around to using it, that has been a disaster for me, worse than fresh manure. The challenge with fresh manure is going to be a lot of times moisture, because you can only get it so dry just off a screw press, which is most of what my dairies work with. I do have some roller presses and things too, but just for ease, let's talk about screw presses. I can only crank that down so hard, and so I end up running with moistures that are a bit higher than what I want to do. So most of the dairies I work with are using manure off of the press, and then some of them are drying it in some additional way, or supplementing with other types of bedding or things to bring the moisture of that entire product down, and that seems to work pretty well. Compost, if you're committed to doing the management on it, can work really well. If you think you're going to take shortcuts there, it also can be really a rough road to go down. After how many times should customers change the sand in a freestall? I think I sample the sand in the back of the stall to answer this question. I have a soil sampler that I use. I take a core sample where the udder is going to lay, so the back third of a stall. And if I see a black line or I have a really strong smell to the sand, we'll change it out. If I don't, they can leave it in there indefinitely as far as I'm concerned. It really doesn't matter. We can do things like sand cultures. I don't do that really that often where I do that more often would be recycled sand, just checking our counts on those. But really, if the sand visually looks clean and doesn't smell, chances are that the bacteria counts are pretty manageable in it, and they can stay a long time. Another way to predict that, of course, is look at how much manure and urine is passed in the back of the stalls. And if you have stalls that are really big, it can be good for cow comfort. If they're too big, then you can have a lot more manure in the stall beds, and certainly that adds to your risk if you can't get it raked out. If you're pretty aggressive about stall raking, then sometimes you can manage that too. So it's all about how much management you want to apply to the situation. And so we often make decisions based on how our honest assessment of how much management horsepower we're going to be able to apply to a situation. In my opinion, the best robot key indicator for udder health issues. That is a tough one. I still, it's not specific to robots, but I look at the same ones I do for a parlor. We're looking at overall somatic cell count of the herd, new intramammary infections, number of chronic cows, and those are the ones we get paid for, and those are the ones that move the needle. You certainly can look at clinical mastitis infections, and the robots vary greatly in how they find mastitis cows and how good they are at flagging it. And there are adjustments that can be made to that. So dairies vary quite a bit in how many cows they'll flag and pull. So I guess I don't just, the actual number of clinical mastitis cases wouldn't be my first indicator, but across a dairy over time, if at least we're being consistent with how many we're flagging and it's a reasonable number, I do look at that and I look for changes in it also. So that's not specific to robots. If you're looking at things specific to robots, I am looking at teat cleanliness. I think that is a huge driver of both bacteria counts and new intramammary infections. And I am going to look at teat health. And I think those are, if you maintain a healthy teat and you can have a clean teat at milking, that is a lot of the battle. The other, of course, would be just maintaining your milking equipment so it's functioning the same way today as when it was installed. Hopefully, they're consistent across units too. I do see that where you got one box in a, some pens that have more than one box. You got one box that is significantly different than the others. That's obviously not ideal either. So, consistent maintenance program on the units you have, clean teats, good teat end health, good teat skin health, and then just the regular indicators: somatic cell count, new intramammary infection rate, and chronic cows in the herd. Fresh cow numbers too. Certainly, we'll look at new infections at first test. And I do see there is a little bit of an issue with dairies that want to go off of DHI test when they start with robots. I look at that, and there are other ways to get some of that information. Depends how comfortable you are with things like conductivity and different ways of flagging cows. And certainly you can get cell count units to go on these robots. Again, harder here in the US, but the rest of the world, those units exist, varying degrees of success and user friendliness, but there are ways to get those numbers, and I still think they're valuable even in robot milking. Seen a couple of residue issues due to employees accidentally entering incorrect treatment information, wrong cow number or wrong treatment duration. Any recommendations to double check these entries? I don't have a good recommendation. I mean, really, data entry is critical. You can't rely on markings because obviously the robots can't look at that. They can't see it. There are not really great ways to do that if you're going to leave the cow where she is at currently, which a lot of robot barns do. And there's obviously advantages to that. So robots are only going to be as good as how you set them up and the data you give them. So the opposite of this, of course, is if you have a cow who's been three-teated, if you program that in right, that quarter is never going to get milked. If I have that in a conventional herd with hired employees milking cows, there's a good chance every once in a while that teat might get attached. So pros and cons, but other than just double checking the data entry, I don't have a great way to do that. Somebody said from New Zealand they do have robots on pasture there in reference to the question we had before. Absolutely, New Zealand has probably more grazing robots than anywhere else in the world. And so a great source of information if you're in one of those markets where there's quite a bit of grazing and your dairies are thinking about or have robots, I would look to New Zealand or Ireland or somewhere like that that's heavily pasture based, and they've got a lot of these things figured out. Have I seen robotic bedding spreaders used? Are they a good option? I have. I think they are. The question is the amount of investment that you need. And there's very, very widely varying options available. Some that are really fancy, like the old school robotic feeders that you used to see on a track that go around and dispense bedding, down to just augers that run over stalls and have drop tubes, or conveyors that have a plow on them and they just push bedding off to one side or the other. I think they can work well. Again, it just depends how much you are willing to invest, but keeping bedding on the stalls, no matter what kind of beds you have, is critical. And so if this is gonna, it's worth investing in if it's gonna allow you to put bedding on those stalls more often and keep a nice, comfortable dry bed. Is a sprayable barrier teat dip better for robotic milking systems to help with environmental mastitis? In general, I'm not a fan of barrier teat dips, no matter what the milking installation is. There is no sound definition of what constitutes a barrier or does not. And a lot of barriers are just low drip formulations. I find there's a couple things relative to robots. If you bed on deep bedded manure solids, let's say, and you send a cow out to a stall bed who's just been dipped with a barrier T-tip, they tend to stay wetter longer. And so you tend to pick up bedding material on them. And so you get a lot of bedding sticking to the teat. That would be one of my concerns. The other is that these systems for cleaning teats aren't really that good at removing the barrier components of the dip. I guess the third would be that the higher the viscosity, which when we talk about low drip formulations, the harder it is to spray and the harder it is to pattern. So it changes your coverage. Now, there are things you can do to adapt for that. And we do these even in times where it's cold in the middle of winter in like the upper Midwest. You can go to larger delivery lines. You can put bigger pumps on. You can change nozzles. So there are ways you can adapt to doing that. And there are dairies that absolutely love barrier dips. So I don't mean to say don't do it. It's just not been my go-to. I think I do a better job of managing environmental mastitis by managing the environment, not trying to just put a barrier over the teat. So my personal preference is not to use them for all the reasons I talked about, but they are management tools in your toolbox, and you shouldn't let me talk you out of them necessarily. I would say just think about the other changes that might go with switching to one of those sprayable barrier dips. How deep of bedding do you suggest over mattresses? 3 inches seems to be the magic number. If you can get at least 3 inches, that's really good. If you told me you could only get 2, that would still be a lot better than nothing. So everything's relative. There's probably a diminishing return somewhere where you just have a deep bed now, but practically speaking, if you're moving from a mattress, if you could get to that 3-4 inch level, that would be just awesome. Your cows would love it. If you really want to sell these to producers, I'll tell you what I've done in the past. I just say take 8 or 10 stalls and put a retainer in and put bedding in there and see what happens. And what you find is those 8 or 10 stalls are almost always full of cows and the others aren't. So those stalls will fill first and they'll always be full of cows. And your real dominant cows tend to be the ones that go there because cows can be really vicious. There's a lot of cow on cow things that happen. And so they'll resource guard with things like water in the middle of summer, but also the most comfortable dry bed. And so you get some of those old boss cows, they just go right in there and they don't move. They just lay there all day. So the cows will tell you and the cows will sell it to your producers. You don't have to worry too much about doing it. As I said, it's going to be very obvious to any producer who's willing to try it. Couple of questions. If there are 2 robots in parallel, why do some cows not want to enter in one robot rather than the other? Just preference. And I would say yes. I think there's a lot of it. There's a lot of data in parlors to say that cows are preferential to one side and tend to either be the first cow in or in the middle or the last cow. And it's very true with robots. And it may come down to just where they feel the most comfortable. But you see this expressed in just which side you want to milk from in robots. So do you have both? Do you have just one? And it makes a difference. Some cows just aren't going to milk one way because they're used to doing it this way. So cows have a preference, and we can't really change that. We can't really force them to go against it. And hopefully, if all the cows are doing it, that tells you something about that particular box or something there. But if it's 1 or 2 cows, then it's just their preference in my experience. Drop down through here. How do I get sterile milk samples from individual cows? Good question. I will lock them up and I'll do it that way. So in the robot, you can do it. You could let the cow be prepped in the robot, and then you could pause the arm. You go in, you could say dip with alcohol and then take your sample there, just like you would in a parlor. You could also do it in lockup. It depends when you want to take that sample, but I've seen it done in all of those ways. Again, personal safety has to be has to be looked out for. So you need to make sure you're pausing the arm for sure. And then you got to think about where you're sticking your arm, which is critical there. So obviously never between any bars would be important. Can you collect it from behind? Can you collect it from the side? Not a perfect scenario there, but there or in lockup is the best ways that I've seen to do it. When evaluating over milking with the Badia units, what targets are you looking for either high mouthpiece vacuum or over milking time? I'm looking to minimize it. I really am trying to get that number down as low as I can without there not being one there. There's not just a huge amount of settings on a lot of the older robots for sure, so I can only get it so low. But I will try and minimize it, and I know that doesn't directly answer your question, but then I'll compare over time across a facility. So I'll say, okay, we've historically been here. Has this changed? Is it still similar to where we're at? And I'll look at things like bimodal milkings too, because we still have some bimodal milkings. I'll evaluate both of those, and I'll look at both how long we're in high mouthpiece vacuum, and then what's the actual vacuum level that we get to when we are milking in an over milking situation. So obviously the higher the vacuum goes, the worse it is. The bigger the liner is, it tends to be closer to what your system vacuum is, unfortunately. So minimize it as much as you can. And I'm not even, we can never milk a cow out completely anyway. There was a question about strip yields. I'm really in robots, I'm often doing more of a plus minus system. If it's real easy to harvest a bunch of milk, that's a plus. If I struggle to harvest any, I can't get much of a strip, that's a minus. You can measure it, but honestly, I like having a free hand when I'm doing it and not having a catch cup. So, and there are good published numbers on strip yield data. So I'm going to refer you to that just out of the sake of being somewhat cognizant. There were 20 minutes, actually we're 30 minutes over now. So will the recording be available online? Yes. This is, if you're a member of NMC, this is a benefit to being a member. I am the membership chair, so I need to say that. We would love to have you as new members if you are not. This is a very vibrant group of professionals and dairymen. And if you have any interest at all in milk quality, and this is very traditional milk quality, of course, but there's a lot more to milk quality than what we talked about here. If you have any interest in milk or you're in the dairy sector, I encourage you to come and see what we're about, and check out our website, check out our social media, and ask a member if you need to. You can ask me. I've got an email, but there's plenty of others. Keith would be happy to talk to you. Just seek out somebody you know who's a member, and what you'll find is it's made a huge impact on our careers and our lives, and made lifelong friends for us. And I look forward to going to the meetings every year, and I'm often calling the people that I have been in the organization with for years, just to pick their brain on what they're doing and what they see. So the professional contacts are invaluable as well. Preference on liner shape. There's some data to say square liners have better teat end health. I think the liner fit matters much more than the shape. So that's what I'll say. If you pick a liner that has the right shape and you run it at the right vacuum settings, I think you can have healthy teats if you are able to also then minimize the amount of unit on time that you've got. So I don't think shape is the most important. The data suggests that round or triangle is a little bit better on teat end health because of the way it collapses, but you can work with a round liner just by getting the settings right and really getting high milk flows and then getting the unit off. How many times a day do I recommend spraying down the robot and cleaning the feed trough? We try and do it every time we do a CIP wash. So that's 2 or 3 times a day usually. If you have to do it more frequently, that tells you something about the cleanliness in those areas. There are a few dairies I work with that have to do it more just because they didn't get the concrete pouring right. We have low spots, concrete wears, and now it doesn't drain. We didn't site our drains properly. Those are all issues to think about, and it's worse in retrofit settings. So when you're retrofitting robots into an existing barn that wasn't designed for this, Oftentimes it's hard to get your slopes right and your gating right and all of those things to where things drain very well and cleanup is very well thought out. So let the unit tell you, but generally I do it right before we do the CIP wash every time. I think that's it for questions. I see some chats. Maybe somebody put something there. I hope this has been informative. I know we went quite a bit over, but as I said, you could have a whole symposium on robot milking, and they do have those. We could have talked about a lot more, and I know there's probably things that we didn't cover that you want to hear about. You got my email. We can talk a lot about offline on things. Any NMC member, look up the board members. It's one long running discussion about milk quality for us. So thank you for being here. We had a great turnout. I hope to see you back at another meeting or another webinar or just something else with milk quality. Stay active in the field and please be active in NMC.
Thank you, Brandon, very much. Throwing up the member benefits again from NMC, and want to thank you and everybody for joining us today. We will have this webinar recording available on the members only side of the website by April 7th. Again, that's where Keith's previous webinar is on the tea condition portfolio and how to use that. Two things that can go hand in hand with yours. So we do encourage folks to log in and check out the members only side of things. Again, thank you all very much for joining us today. This concludes our webinar.